All right, let's jump straight into this. Imagine you've spent weeks perfectly tuning your AI coding agents, right? You've given them strict review checklists, detailed migration playbooks, these beautifully complex scaffolding routines. They are literally tailored to exactly how you work. But then, you spin up a Docker Sandbox to run those agents securely in an isolated micro VM, and poof, it's just a completely blank slate. The isolation is doing its job perfectly for sure, but it just wiped out all your highly tuned, personalized AI agent skills. Welcome to this explainer. Today we're going to unpack this core developer dilemma with Docker Sandboxes. How do we get that ironclad isolation without giving our agents total amnesia? Here is our roadmap for today's explainer. First, we'll hit 1, the isolation dilemma. Then 2, shared agent skills explained, followed by 3, importing to the store, 4, the security trust boundary, 5, project scope skills via kits, and finally 6, choosing the right approach. Let's get to it. Starting off with Section 1, the isolation dilemma. So think of a Docker Sandbox micro VM as a high-security bank vault. Every single agent you run gets its own isolated file system and dedicated network. And honestly, that isolation is the whole point. It stops agents from just casually wandering around your host's home directory. But exactly like being locked in an empty vault, it completely strips the agent of its tools. And what's really fascinating here is how those left-behind tools are actually defined. An agent skill is quite literally just a directory on your host with a skill.md file sitting right at the root. It acts as a reusable instruction set. But here's the kicker. The description written in that metadata isn't just window dressing. No way. It's the actual trigger. Your AI agent actively reads that description to decide when to jump into action. It's doing real work. Moving on to Section 2, Shared Agent Skills Explained. Introduced back in SDBX version 0.37, we have this carefully constructed bridge to get your user-level skills into the sandbox. Now notice the routing magic at play here. On your host machine, different AI agents naturally look in totally different directories, right? Claude Code looks in one place, Cursor in another, Copilot in a third. But once we're inside the sandbox, they all seamlessly feed into one single agent-neutral shared store. It's pretty brilliant. This means a skill you originally authored for Cursor can seamlessly pop up and work for Claude. The store automatically mounts to the correct target path for whichever agent you happen to be running when that sandbox boots up. Which brings us to Section 3, importing to the store. Let's look at the actual mechanics of moving these tools safely under that vault door. Because sharing is an active copy and not just a live mount of your home directory, the process is straightforward, but you really have to know the rules. Step 1. Always run SBX skills import-dry run. This is your best friend. It gives you a preview of what's going to be copied into the host side state store, and trust me, saves you from accidentally deleting your own work. Step 2, resolve your collisions. Because all agents feed into that one central store, if you have 2 skills with the exact same directory name, the first one scanned wins and it will just shadow the other. Step 3, run the actual import. And it is absolutely crucial to note here that importing replaces the entire directory. It doesn't just merge files. So if you've got a stale helper script hanging around in the store, the import completely overwrites the whole folder to perfectly match your host source. Now, let's rapid fire through 3 tricky lifecycle rules you absolutely need to remember. First up, upgrading your SBX version doesn't magically retrofit sharing to older sandboxes. You actually have to recreate them. Second, and this is a big one, the -no share skills flag only applies at the exact moment of sandbox creation. You cannot toggle this on a running sandbox. Participation in that shared store is permanently decided the very second the sandbox is born. Finally, if you import updates while a session is already open, just keep in mind that some agents only scan at startup, so you might just need to launch a brand new session to trigger a rescan. All right, Section 4, the security trust boundary. Whenever we punch a hole through an isolation layer for convenience, we absolutely have to talk about security. Let me ask you this. What actually happens if a sandbox gets compromised? Well, let's say you spin up a sandbox for some untrusted public repo. Here's the catch. By default, that shared skills store is mounted read-write. That's what allows agents to refine a skill and persist it. But it also means any malicious code in that sandbox can secretly alter the SKMD or the helper scripts hiding inside that shared store. To put it in the starkest terms possible, the source documentation issues this warning, and I quote, "A compromised or prompt injection in one sandbox becomes an input to every other sandbox that shares the store." Really let that sink in for a second. A poison skill edited by Sandbox A can easily be loaded and executed later by Sandbox B. By using the shared store, you are actively opting into a single trust boundary that connects every participating sandbox. While it doesn't execute back on your host machine, it absolutely 100% cross-contaminates your sandboxes. Fortunately, you have an immediate safety valve. If you're running an unfamiliar public repository, maybe an experimental kit, or literally anything you wouldn't trust directly on your bare metal host machine, you must create that sandbox using the -no share skills flag. This guarantees that the untrusted sandbox is kept completely outside the shared trust boundary, ensuring a poisoned skill just cannot follow it out. Next up, Section 5, Project Scoped Skills via Kits. This is our alternative architectural solution for those untrusted environments. Instead of bridging to a globally shared user folder, kits are these declarative YAML artifacts that extend just one specific sandbox. They drop project scoped skills straight into the files/workspace directory inside that particular micro VM. Because these skills completely bypass the host's user-level configuration, they literally live and die with that single sandbox. They version right alongside your project, and they never, ever enter that cross-sandbox trust boundary. It's a really elegant workaround. And finally, Section 6, Choosing the Right Approach. Let's build a clear framework for your daily development. Here's the ultimate showdown. On one side, we have the shared store. It operates at the user level, spans across multiple sandboxes, is read-write by default, and operates within a shared trust boundary. On the other side, we have kits. They operate at the project level, sit inside a single sandbox workspace, are entirely isolated, and have a fully contained trust boundary. So what's the rule of thumb here? Use the shared store for your personal, trusted scaffolding routines that you just want available in every single session. But reach for kits when a skill encodes knowledge for a specific repository or when you absolutely need it to stay out of the shared trust boundary. And that really brings us to the core reality of Docker Sandboxes. Isolation is the primary feature here, and every single convenience that reaches across it is a deliberate, bounded exception. So I want to leave you with a final thought to ponder today. Which of your workflows will you intentionally bring across that isolation boundary, and which will you safely leave locked inside the vault? Take some time to evaluate your own AI agent routines, map out your personal security boundaries, and definitely dive into the documentation to build your perfect setup. Until next time, happy building!